Hi sir, so today my friend and I will present about final lab report for ME Lab 1. This is all my group members and my name is Nik Muhammad Alif bin Nik Ali. So I will present about Lab 1. Lab 1 introduce us to meteorology, which is the science of measurement. Accurate measurements are very important in manufacturing because even a small error can affect product quality and assembly. The objective of this lab are to expose students to different measuring tools and allow us to use them practically or workplace while understanding their applications and limitations. Different measurements instruments have different level of precision. The vernier caliper and micrometer are more accurate than the steel rule, while the dial indicator is used to detect very small variations in dimensions. So the conclusions, this laboratory helps us to understand the importance of measurements in engineering and gave us practical experience using different measurement instrument correctly.
And now for the lab 2, which is benchwork. What is benchwork? Benchwork is actually a fundamental mechanical engineering skill. It uses hand tools to shape, cut, and finish materials. It is important in manufacturing and fabrication that requires precision, accuracy, and safety. What is the objective? The objective is to identify various hand tools, understand application of hand tools, use tools safely and correctly, select proper tools for trading, and also produce a benchwork project. In this lab, the tools that we use is bench vise, hacksaw, files, scriber, center punch, vernier caliper, reamer, and also hand tap set, M6. And for the material, the raw material is a mild steel plate. The size is 102 millimeter times 552 millimeter. The thickness is 6 millimeter. For the procedure, first we plan by study the drawing and prepare the tools. After we plan, we do a marking at the metal plate where to cut and also how much we need to cut. Then after that, we do the cutting using hacksaw. After we cut, of course, we need to do filling to make sure that the edge of the metal plate is smooth. And then we do drilling. We drill at the marked position. After that, we do reaming to smooth and enlarge the holes if needed. And then we do threading to create threads using an M6 and also M8 tab. And after that, as usual, we do the inspection to measure and check the final workpiece. As for the result of our experiment, our lab, on my left side is the expectation, and on my right side is the final result. Overall, our workpiece closely matched the required dimension and shape. However, there were small differences caused by manual operation as cutting and filling. Minor deviation were observed in some dimension and surface finish. The drill hole and threaded section were successfully produced according to the design requirement. These differences are normal in benchwork because the process depends heavily on skill and accuracy and to handling, and so on. Despite this minor deviation, the final workpiece functional and made the main objective of the experiment.
Good morning, everyone. Today I will be presenting our laboratory experiment for the turning process experiments. In this experiment, we learned how to operate an engine letter machines and perform basic turning operations to produce a workpiece with required dimensions. So, turning is a machining process that removes materials from a rotating workpiece using a cutting tool. The process is carried out on a letter machines and is commonly used to produce cylindrical components such as the pins and the machine parts. So, this process is important because it helps achieve accurate dimensions and good surface finish in manufacturing. The objective of this experiment was to learn basic turning operations, understand the operations of letter machines, identify the tools using during machining, apply safety procedures, and produce a workpiece with accurate dimensions. Through these experiments, we gain both theoretical knowledge and practical machining skills. For these experiments, we use an engine letter machines as the main machines, and the tools used were a vernier caliper, steel ruler, and a carbide cutting tool. The workpiece material was a mild steel bar with a diameter of approximately 40 millimeters. These tools were used for machining and measuring the dimensions of the workpiece. These are the main turning operations, which is facing, rough turnings, semi-finish turning, finish turning, and the purpose of this is facing turning is to create a flat surface, rough turning is to remove the large material, semi-finish turning is to improve the accuracy, and a finish turning is to find the final dimensions at the smooth surface. These are the procedures of the experiments. The experiment began with a job planning and the machine setups. Next, the cutting tool and the workpiece were installed currently. We then performed several machining operations, including facing, rough turning, semi-finish turning, and the finish turnings. Finally, the dimension of the workpiece were measured and inspected to ensure accuracy. The final measurements shows that the workpiece dimensions were close to the target values. The target length was 100 millimeters and the measured value was 99.85 millimeters. For the diameters, the measured values were 22.06 millimeters and 16.08 millimeters. All measurements were within the acceptable tolerance range, indicating that the machining process was successful. There are several challenges were encountered during the experiments. This includes difficulty in achieving accurate dimensions, surface finish issues, tool alignment problems, and the measurement errors. This challenge highlighted the importance of proper machine setups, careful measurements, and correct machining parameters. So, in conclusions, the turning process experiment was successfully completed. We learned how to operate an engine letter machines, perform basic turning operations, and measure workpiece dimension accurately. The experiments also improved our understandings of machining principles and workshop safety practice. Thank you for listening.
Assalamu alaikum. My name is Mohammad Shaikh bin Sadiq. My metric ID is MA24195. Today I will explain our lab report 4. Milling process. Introduction. Milling process is a machining process that removes materials from workpiece using a rotating multi-point cutter tool. It is widely used in manufacturing industries to produce flat surface, slots, globes, holes, and other complex shape with the with high accuracy and good surface finish. The purpose of experiment was to learn the setup and operation of a milling machine and to produce a workpiece according to the given engineering drawing while maintaining dimensional accuracy. Learning object. The learning objects of this experiment were: first, to safety performance basic milling operation; second, to understand the procedures involved in milling process; third, to identify the
functions of milling machines, tools, and accessories. Fourth, to understand workshop safety regulation. Fifth, the to recognize the importance of dimensional accuracies in machine. And finally, to develop particle machine skill through hand to experience. Basic theory. Now, let's explain the basic theory behind the milling process. Milling is material removal process where rotating cutter removes excess material from a stationary workpiece. The main components of milling machine are the spindle, work table, cutter, and feed mechanism. Several machining operations are involved in this experiment, including face milling, slot milling, drilling, counter boring, and tapping. Face milling is used to produce flat surface. Slot milling creates slots. Drilling produces holes. Counter boring enlarges part of the hole, and tapping creates internal threads. Dimensional accuracy is very important behind finishing component must meet the specifications started in the engineering drawing. Therefore, proper machine setup, correct cutting parameter, and accurate measurement are required to achieve good machine quality. Here, the apparatus and procedure I have already told explain. Here is the required measurement, and here the observation, the measurement result, what is required and what we got, length, width, the height, slot length, and slot width. Here the problem what we faced, like difficulty maintaining dimensional accuracies, machine vibration, work pitch align issues, tool wear, and measurement error. Source of error is basically human error. Sometimes it's incorrect of cutter position, sometimes machine's vibration and tool deflation. And suggestion how to improve. Here is said, like verify dimensions before machining, and work pitch surely, like use sharp cutting tool and take multiple measurement and apply suitable cutting parameters and cutting fluid. In conclusion, the experiment successfully introduced milling machine operation. Various operations such as face milling, slot milling, drilling, counter boring, and tapping were performed. The workpiece closely matched the engineering drawing specifications. Valuable particle experience was gained in milling and manufacturing process. Does anyone have questions? If you don't have any question, then thank you.